Hello everyone. So today we will start with the next topic of operating system, that is the disk scheduling. So before going to disk scheduling algorithms, we will first understand what is the exact structure of the disk. So the diagram shows the structure of the disk. So if you observe the structure of the disk, then you will observe that there are major three parts in a disk. First one is called as the platter. So this whole part is called as the platter. This one is the platter. This is the second platter, this is the third platter. So circular disk is called as the platter in the hard disk. Now next part in the disk is called as this track. So this particular circular part or the every platter is divided into tracks. So the smaller circles on the disk are called as the tracks, and every track is divided into again a subparts, and every divided part of a track is called as the sector. So you will observe this is a sector here. Okay, so like this, every track has the multiple sectors, every platter has the multiple tracks on it. Now, the next is a cylinder. Okay, now what exactly is a cylinder? So same track of every platter. So for example, say this is the track on first platter, this is the track on second platter, and this is the track on third platter. So same numbered track on every platter is called as the cylinder. So like this will be one of the cylinders. If you take next track here, next track here, next track here, so combination of these three tracks will form the another cylinder. So cylinder is nothing but this same number track of every platter is called as the cylinder. Combination of same number track of every platter is called as the cylinder. Okay, now this is the different parts of the hard disk: platter, then track, then sector, and a cylinder. Now there are two movements in the disk. One is called as the angular movement, that is given by this spindle, and it rotates in a circular direction. And second one is called as the arm assembly, that moves forward and backward. So this arm assembly is responsible for detecting a particular track or locating a particular track on a platter, and the spindle is responsible for detecting a particular sector in a track. So in this way the read and write inside a hard disk will be done. Okay, so this is the basic structure of the disk. Now we will move to the next topic, that is the disk scheduling algorithm. So there are different disk scheduling algorithms. So some of the algorithms are mentioned here. So first algorithm is a FCFS algorithm. So what FCFS stands for? FCFS stands for the first come first served. That means the request which are arriving in the order, they will be processed in the same order. That means whatever the requests that have arrived first, that will be processed first. That is the basic fundamental behind this algorithm. Next is the shortest seek time first algorithm. So shortest seek time first means, for example, say current disk position is at 63, and the two the next request are, let us say, 65, another request is 70. So for this, from this current position, that is the 63, the nearest position or nearest sector is a sector number 65. So we can move to 65 in minimum time, and this will require the maximum time. So distance here is a 2, distance here is a 7. So for accessing the location 65, it requires only 2 distance. For accessing the location 70, it requires the 7 distance to be traveled. So SSTF algorithm moves or processes the next request which requires the minimum distance. So this is a SSTF algorithm. Next algorithm is a scan algorithm. Okay, so with example we will saw a scan algorithm. So scan algorithm works like this. So inside a scan, it considers one direction. Then for example, say it is selecting a forward direction. This is the current location. From current location, it will check the take the one direction. It will process all the requests in that direction and will reach to the end of the disk. So this is the end of the disk. So this will process all the requests in this direction and will reach end of the disk, and from end of the disk it will reverse the direction. So as it was going in this direction, now it will change the direction to this. So it will reverse the direction and will process all the requests in the reverse direction like this. So this is a scan algorithm. Now next is a look algorithm. So what happens in a look algorithm? So look algorithm is somewhat like this. So inside a look algorithm, the difference between the scan and look is that in scan it checks or it considers one direction and moves forward in the same direction and processes all requests, and on reaching to the final request, it reaches to the end of the disk. So this is the end of the disk. But inside a look algorithm, on reaching to the last request in that direction, it will reverse the direction and will process the remaining request. This is called as the look algorithm. Then next is the cscan and clook. So what cscan is, so like in a scan algorithm, it reaches to the end of the disk. It reaches to the end of the disk like this. So it will start and serve all the requests in that direction and will reach end of the disk in a scan. Now in cscan, what is the difference? From the end of the disk, it will reverse the direction and will reach another end of the disk, and then again will reverse the direction and will process the remaining request in the same direction. So this is called as the cscan algorithm. So what is the cscan and scan? Difference between scan and cscan. In scan algorithm, it reaches to the end of the disk and reverses the direction with processing of the request. But here in cscan, it reverses the direction and reaches the another end of the disk, and from then onwards it again changes the direction and processes the remaining request in that direction. Okay, so this is called as the cscan algorithm. Now you might have taken a look on the next algorithm, that is a clook algorithm. So what is clook algorithm? Like a look algorithm, in look algorithm we process the request, we reach to the end last request in that direction, and from here we change the direction and process the remaining request. But here in clook algorithm, change the direction and come to the first request in opposite direction, and then again change the direction and process the remaining request. So this is called as the clook algorithm. Okay, we will study this each algorithm with the help of the example. Let us take the first example. Okay, so this is the first example we have been given. So what is this example? This example is given the disk. Okay, so summary of this example is written here. Total cylinders on a disk are 200. These are numbered from 0 to 199. The FIFO order of the request. FIFO order means the order in which these requests have arrived, that is first in, first out. So these requests are first is 27, 129 up to the last request, that is 120. And one more thing is provided to us, that current position of the disk is at 63. Current position of the disk is at 63. And the question is, what is the distance that is required to be traveled? The total distance that disk arm moves to satisfy all the pending requests for the following disk scheduling algorithms. Okay, so we will solve it for all the algorithms. First algorithm we will check for the FCFS. Okay, now we have given a current disk position. Current disk position is given as a 63. Okay, so this is a 63 disk position. Okay, now from 63 we will try to move in the move to the first request. So what is the first request? First request is a 27. So we will move to the first request. So first request will be somewhat approximately here. So these problems can be easily solved with the help of the graphs. So you should draw a graph. We have given total 200 cylinders. So we have marked this line from 0 to 199. Then we have approximately taken some units here, 25, 50, 75 up to 200 or 199. Okay, so the graph doesn't require measurementally correct, but it should be approximately. So we have moved to the next request, that is a 27. From 63 approximately here, 27 will be approximately here. Now next request is a 129. Okay, now next request is a 129. So we have to move again with changed direction. So this 129 will be somewhere here. So we will mark this as a 129. Okay, from 129 we have to move to 110. So again change in direction. So we will move to the next request. It is a 110. Okay, from 110 we have to move to 186. Again a change in direction. So this is a 186. From 186 we have to move to 147. So 147 change in direction. This is a 147. Okay, now from 147 to 41 and from 41 to 10. 147 to the next request is a 41 approximately here. This is 41. From 41 to 10 approximately somewhere here. From 10 we have to move to 64. 10 to the 64, and from 64 to the 120. This is 120. So this is the processing of the disk request according to the algorithm. Which algorithm? the FCFS, first come first serve. That means whatever the order in which these requests have arrived in the processor, in the same order we have to process the request. Okay, now we have to calculate the distance. So how distance will get calculated? So let us calculate the distance. So distance is calculated as, so distance is absolute difference between current position, current minus next request. For example, say let us say this as a we will write the distances here. So first current position is 63, we have moved to 27. So what is the difference? Current is 63, next is 27. So this is the absolute value between 63 minus 27 or 27 minus 63. Whatever you will do, we have to write the absolute value. So this difference is 63 minus 27 is 36. Okay, now next, now the current position is 27, we have moved to 129. So the distance is 27 to 129. So this we will write as 27 minus 129. We have to write the absolute value. So this will be a 102. Then 129 to 110. Next distance is 129 to minus 110. So this distance is a 90. Then 129 to this we have calculated 110 to 186. So next is 110 minus 186. So this will be 110 minus 186 equals to 76. From 186 to 147. But here you can observe that from 147 we have not changed the direction. We are going in the same direction. So we can directly calculate this much distance from this to this. So this much distance is 186 minus 10. So 186 minus 10. So this will be 176. Okay, from 176 next distance we can directly calculate as this much distance. So this distance is a 120, that is last request, and current request is a 10. So 10 minus 120, this is equals to how much? 10 minus 120 is 110. Okay, now next add or calculate the total distance. We have been asked to calculate the total distance. So what is total distance? This 6 plus 2 8 plus 9 17 plus 6 23 29, carry 2 2 1 3 10 17 18 21, carry 2 2 1 3 4 5. So total distance is a 519. That is required by FCFS algorithm to be traveled. So thank you for listening to the lecture. Next lecture we will study the next algorithms, SSTF, scan, scan, look and CLOOK algorithms. So thank you very much.